Hi everyone, this is Miss Medrano, and I'm going to go over velocity graph with you for your final. And so we're going to make your velocity graph, and based on the position graph that you had created from the page before. So let's review our velocity graphs. Let's take a look at what we had learned in the constant velocity section. So we have velocity on our y-axis and time on our x-axis. And for constant velocity, it's just going to make a straight flat line with no slope, or with a slope of 0. So this is constant velocity. Next, we're going to take a look at speeding up. So speeding up velocity time graph is going to look like, so it's going to start from 0 meters per second, and then it's going to go up to some number. All right, so let's go with 0 centimeters per second, since your final is in centimeters. And this number right here, the final velocity is some non-zero number. All right, and so maybe it's 5 centimeters per second, maybe it's 15 centimeters per second, whatever it is, it's some non-zero number. And it's going to be greater than 0 centimeters per second. Now let's take a look if it's slowing down. And let's just label it speeding up. And so for slowing down, we're going to see a kind of different slope, right? So we're going to see it go down. And so for the final velocity, it's going to be your non-zero number of 15 centimeters per second, maybe it's 5 centimeters per second. And then you have your, that was your initial velocity. So initial velocity would be 15 centimeters per second or 5 centimeters per second, and your final velocity is going to be 0 centimeters per second. And so that's slowing down. Okay. And so when we go back to this graph, you're just going to draw your initial and your final point, and then draw the line between them. And so that's for part 1. And for part 2, you're going to start with your initial non-zero number and your final, and so that's part 2. Okay. Now let's take a look and make sure to label them. Label the points. All right, so now let's take a look at what this information says down here. Okay, you're going to use the information from your position graph. So you calculated your displacement from your position graph. Okay, so from your position graph. And we're going to solve for velocity, which is your unknown. So we don't know what that number is. And we're going to use the time it took to travel, for how long it took your car to move. So this is how long it took your car to move. And remember, it's just part 1 or part 2, right? So if you did speeding up, then your car did just the first part, right? So speeding up, how long it took your car to go from the initial point to that middle section, right? So time to reach max speed. And then if you're doing slowing down, you are going to do this part. So the time it took to stop. Okay, so let's just do like a practice 1, right? So let's say you had a movement of 10 centimeters, and we don't know what the velocity is since we're trying to figure it out. And it took your car 2.5 seconds to, oh, whoops, I'm sorry, let me rewrite this. It should be 1/2 since the speed is changing, right? So 1/2 and velocity times the time of 2.5 seconds. And so we're going to just simplify. So 2.5 times 1/2. So you're going to take half of 2.5. you're going to have 10 centimeters is equal to 1.25 seconds times your unknown. And then to get your unknown by itself, you're going to divide by 1.25 seconds. Okay. And so now, since I've run out of room, I'm just going to go over here to this other side. And so I have velocity is equal to 10 centimeters divided by 1.25 seconds. And I have velocity is equal to, so 10 divided by 1.25 is going to give us 8 centimeters per second. And this would be our non-zero velocity of our chosen motion, right? So maybe it's so this is, my car went 8 centimeters per second at its fastest. Okay, and so this is the example of showing your work, and you want to make sure that that you do show your work really well. So example of showing work. Okay, so make sure you do the same thing. Now, so clearly show your work at the right. Be sure to label the starting and ending points on the graph. So we're going to go back here. And so maybe it was here that I calculated for 8 centimeters per second, or maybe it was for here that I calculated for 8 centimeters per second. Okay, so this is your non-zero velocity number that you just calculated here. All right, so now let's go back to this one on the right. We're going to go to the graph calculating the acceleration, and the acceleration is just going to be acceleration is equal to final velocity minus initial velocity over final time minus initial time. And so you're just going to pick whatever points you chose, right? So this is going to be your initial. So initial, and this is your final. All right, and that's for speeding up. And if you are choosing slowing down, then this is your initial, and then this is your final. And then you would just take those points. Okay. Now, the Y-intercept on our graph is going to tell us something about the motion of our car. So the Y-intercept is going to be along the Y-axis, which is velocity. And so here the Y-intercept would be 8 centimeters per second for slowing down, or it would be 0 centimeters per second for speeding up. Now remember, 8 is just my pretend number, okay? And so now we're going to take a look at the math model. And the math model is what we did with algebra. Okay, so for algebra, it started off with y is equal to mx plus b. Now let's just make this a little bit bigger so that we can focus on this section. Now, y is going to be whatever is on our y-axis. Okay, and on our y-axis is velocity. Okay. Now, on our m here is our slope. Okay, and the slope is represented on the velocity time graph. The slope is our acceleration. Now, our x-axis is our so our x-axis is our time. Okay, so the x-axis tells us about our time, and then our b tells us information of our y-intercept, and that is our initial velocity. All right, so then when we write this out, we are going to keep the y and the x, since that's the one that kind of keeps changing each time, right? So those are our variables. And so our velocity is equal to our acceleration. So whatever it is that you solved for. So I'm just going to leave that as a blank. And remember that the units for acceleration is centimeters per second, okay, times time plus initial velocity. Or you will have a number for initial velocity. Maybe it's 0 or some other thing, right? So I'll leave this blank. So here would be your slope with units. And then this would be your y-intercept. Remember, it's your initial velocity. So the units for that would be centimeters per second. Okay, and now at the bottom of our page, we have right for every sentence. And so we're going to take our slope, and that's some number, right? And the units for that are centimeters per second. So we would say for every 1 second, okay, the car, and then you would say something about what the car is doing. All right, now to just kind of recap everything that we just went through. Okay, so on our velocity time graphs, we need to make sure we have a sketch of the shape of graph. So shape of graph, we need to take a look at the labels. So label the initial and final points. You need to make sure that you have identified or solve for velocity, the non-zero number. So you're going to either start off with 0 or end with a 0. Okay, use the displacement from the position graph. And then you're going to solve for velocity. I know I said that already. Using delta x is equal to velocity times, is going to equal to 1/2 velocity times time, with velocity being the thing that you're going to be solving for. Okay, so this one's pretty important. I'm going to put that in a yellow box so you remember. And then you're going to calculate acceleration. And you're going to use acceleration is equal to final velocity minus initial velocity over final time minus initial time. And don't forget your units. Okay, so let's just highlight that. Don't forget your units. Okay. Also, don't forget to have your y-intercept, meaning your math model with variables. Don't forget the units, and then your for every something sentence. Okay, so here's the review with the rubric, and then here is kind of the overall for what we're doing here. All right, thanks everyone.